Okay, so we're going to learn something called factorial notation today and how to work with factorial notation to solve permutation problems. And did we talk about what a permutation is yesterday? I don't think so. So we'll talk about what a permutation is as well. Marley volunteers after school at a daycare center near Vimy Ridge Academy each afternoon around 4 p.m. She lines up her group of children at the water fountain to get a drink of water. Determine the number of arrangements that the 6 children can form while lining up to drink. So when we're starting this problem, how many different spots can they be in if we're lining them up? How many kids do we have? 6. We have 6 kids. So they can either be first, second, third, fourth, fifth, sixth. Now, if you're dealing with children, is this a situation where we can have repeats? No. You can't have a clone of a cat, right? Once you put one kid in that spot, he's in that spot. Obviously, there's no repeats in this type of problem. So in the very first spot, how many kids do you have to choose from to put in the first spot? You have 6 to choose from. So now that you put one in there, the second spot, how many left to choose from? 5, because you can't repeat a child. And then the third spot, you now have how many kids to choose from? 4, 3, 2, 1. Okay, and so what does that equal to? Type that in. 720. Combinations. Now, 6 times 5 times 4 times 3 times 2 times 1, we can actually write that as 6 factorial. And factorial looks like an exclamation mark. So you say it like 6. Did you get it? No? Okay. That's not funny? Okay. So that is a factorial. Factorial. That's factorial. 6 factorial means 6 times 5 times 4 times 3 times 2 times 1. That is what factorial is. And so there actually is a way to type that into your calculator. And how do we do that? Well, let's write that down. So in my calculator, of course, I would push the 6. To get the factorial, you want to push the math button. So we get it from math. And if you push math, we actually want to go 1 arrow to the left of probability or 3 arrows to the right. I find 1 left is a lot faster. So we want to go, I push 1 arrow, the blue arrow, so that I can get to probability. And then, do you see it? Number 4 is the factorial. Math, left arrow, 4. So to type that into our calculator a lot faster, you're going to have 6, math, arrow, 4, and there we go, 720. Okay, it's a lot faster way to type it in. That calculator will not have it unless, yes, you just need to trade me something for it. Come on, guys. So I'm going to highlight this. This is a really important thing, okay? Permutation is an arrangement of objects in a definite order. So what does that mean if there's a definite order? That means order matters, okay? So permutations, or a lot of times we call them perms. A perm? No? Okay. I'm not funny today, apparently. Order matters in a perm. So we're going to learn about something called a combination later on, and a combination order doesn't matter. Permutations order matters because there's a definite order when we. So for example, here's 3 different objects, A, B, and C, and we're saying the order of the objects matters. When we were lining up the kids in the water fountain, did the order matter? Yeah, because we want to know how many different arrangements we can make and how they can stand into different orders. So order matters. So there's times when order matters, and there's times where order doesn't. Let me give you an example. If you have a 5-card hand, if I have 5 different cards in there, like ace, king, queen, jack, 10 clubs, does the order matter when you're holding that hand? No, like when you draw cards, you have five, you're choosing five of them, and the order that you hold them in your hand doesn't matter. Okay? When you're arranging objects, whenever you're arranging an object, order matters. Okay? So if I was like arranging letters, the letters A, B, C, how many different arrangements can I make of those letters? Order matters. That's a permutation. We're going to use, in permutation, we're going to use this factorial notation. So we're going to practice learning about factorial today. So n factorial, just like 6 factorial, or 5 factorial, or 3 factorial, let's say 3 factorial because it's a lot shorter, would be what? 3 times 2 times 1. That would be 3 factorial. Okay? 4 factorial would be 4 times 3 times 2 times 1. 5 factorial would be 5 times 4 times 3 times 2 times 1. So what would n factorial be? N factorial would be n. Notice how we're subtracting 1 each time. So n times n minus 1 times n minus 2 times n minus 3, all the way until we get to 3 times 2 times 1. That's n factorial. Okay? So turn the page, or look at the next page. Okay? It's really important to know that when we use n factorial, that the n is defined only for values that belong to the natural set of numbers. So natural numbers are counting numbers, and that's important to know. So you don't have a negative factorial. And because we're dealing with objects, right? You can't have negative objects. I can't arrange negative 5 kids. So it's always positive whole numbers. So please evaluate 6 factorial. Well, we just did that one. Do you guys remember what it was in your calculators? 720. Okay. Now I'm going to show you how to do this one algebraically, but also with your calculator. Okay, so first algebraically, how else could I write 5 factorial? 5 times 4 times 3 times 2 times 1 over 3 factorial, or 3. You're excited about it? No? 3 times 2 times 1. I'm the only one awake today. And what can we do here? Does anyone notice what we can do? Yes, it's magic. The 3's can cancel. The 2's can reduce out as well. And the 1's. I should say reduce. So I cancel, they reduce to 1. So we're actually just left with 5 times 4. So 5 factorial over 3 factorial is 5 times 4. Or what's that equal to? 5 times 4 is? Yeah, we should know that. 20. In your calculators, if you were to type this in, 5, what button do we push next? It's math, right arrow, number 4, divided by 3, math, right arrow, number 4. Or left arrow, thank you. I don't know my lefts or my rights. 20, there it is. Okay, so we can evaluate with our calculator. Now, why is it good to be able to do this right now with numbers? Because right away we're going to try it with variables. And so then you have to get this concept down of expanding. Okay, 9 times 8 factorial. There's another way we can write this. Does anyone know how else you could write this? If this is 9 times, and what's 8 factorial? 8 times, I know you know this, 7, I think I know you know this, times 6 times 5 times 4 times 3 times 2 times 1. How else could this have been written? 9 factorial. Right, 9 times 8 factorial could have also been 9 factorial. It's the same thing as 9 factorial. So to save time in our calculators, let's plug that in. 9 left arrow, oh, first math, left arrow, 4. Or you could type in 9 times 8, math, left over 4, and it gives you the same thing. Okay, 362,880. Don't be afraid of large numbers in this unit. Okay? You'll notice that we're dealing with combinations, and often there's a lot of combinations. What? Your calculator might be set up weird. I can check that out in a second. Okay? All right, 3 factorial times 2 factorial. Well, 3 factorial is 3 times 2 times 1. And 2 factorial is what? A waste of energy. Why is 2 factorial a waste of energy? Because what is 2 factorial? 2 times 1. It's just 2. We could have just wrote 2. But, so 3 times 2 times 1 is what? 6 times 2, or 12. In your calculator, I'm pretty sure you don't even have to write the multiplication between them. So 3 math left arrow 4, and then 2 math left over 4. So automatically it multiplies them, or you can put the multiplication symbol between them if you like. Okay, really quickly, if you had a question like this, 5 factorial over 3 factorial 2 factorial, how would I enter that in my calculator? What would I have to need? What do I need? Brackets, where? Wrapping the 3 and the 2 together, because they're together on the denominator. And so in order for it to divide by both of them, we need to wrap them together, like a present. So 5 math left 4 divided by bracket 3 math 4, and then the 2 factorial. Okay, you'd have to wrap that in brackets to enter in that properly. If there's more than one thing on your denominator, it has to be wrapped. Okay, so whenever we're talking about a permutation, how many permutations, it's really saying how many arrangements. Okay, because we're arranging a certain set of objects. Those objects could be people. We shouldn't objectify people, but we are in this unit. Oh man. Okay, how many permutations are possible? I think that's supposed to say if Ken, Sarah, and Raj. Oh, of. No, that's right. I can't read. Of Ken, Sarah, and Raj when they line up to buy a slice of pizza. Okay, so how many different slots can we put them in? In a line. If there's 3 people, there's going to be how many slots for them to stand in? Either you can be what position, or what position? First, second, or third? First, second, or third. So we want to put the lines in. So the very first spot, how many people do we have to choose from? How many objects can we put in the first spot to begin off with? We have 3. Can you repeat people? No, unless they're clones. Or, yeah, not happening. So 2 left and 1. So how else could you have wrote this? 3 factorial, which equals, this is write it using factorial notation. 3 times 2 times 1 is? It's Friday. Okay, write the following expressions using factorial notation. So how else can you write 5 times 4 times 3 times 2 times 1? It's easy. 5, 5, 5. Like that. 5 factorial. Okay, ha! We want to write this with factorial notation? But where did the 6 times 5 times 4 times 3 times 2 times 1 go? Well, how else could we write this? Well, let's add in 6 times 5 times 4 times 3 times 2 times 1. And where are we else going to put the 6 times 5 times 4 times 3 times 2 times 1? It must have been reduced out. We divide by it, right? So these guys would have been reduced out. So how else can we, how would that look like now in factorial notation? 9 factorial over 6 factorial. Make sense? Okay. All right. What's missing from the top if we wanted to write 15 factorial? The 12. So That's a lot to write. If I'm going to put 12 times all the way to 2 times 1, where would it have to go so that it would have canceled? So we still have the 4 times 3 times 2 times 1. So if I'm adding in the 12 times 11 times 10 times 9 times 8 and all the way to 1, I'm going to have to add it into the bottom. 12 times 11 times 2 times 1. So on the numerator, how could we write the numerator now? I don't know why this won't. There we go. What would that be now? I'm going to call on you individually. No one offers a response. Someone from this side of the house? Okay, Levi? Yeah? This is a 4 factorial, 12 factorial. Beautiful. So this was already 4 factorial. And then the 12 must have been canceled, so the 12 factorial on the bottom. Beautiful. Thank you, Levi. Okay. Woo! Flying through factorials. Because they're so exciting. Okay. How else can we write 8 times 7 times 6 factorial? 8 factorial. Thank you, Owen. Evaluate the expression. So 8 factorial is 8 math arrow 4. 40,320. So if we're arranging 8 people in a line, that's how many arrangements we can make. That's a lot of arrangements. Try drawing that out. Yeah. Okay. So what can 12 factorial divided by 10 factorial actually be written as? In a simplified form. Well, we can write 12 factorial as 12 times 11 times 10 factorial. Would you agree that that's the same as 12 factorial? Yes? All over 10 factorial, what happens with the 10 factorials? They cancel out or reduce out. Well, because instead of writing it all out, we could just write that as 10 factorial, right? Instead of writing the 10 times 9 times 8 times 7 times 6 times 5. Saves a lot of writing. That's what we did last question. Oh, too much, right? So instead, we can write 12 factorial because we know then the 10s will cancel. So 12 times 11, does anyone know what 12 times 11 is? 132. Okay. So we take the larger one, always the larger one, and you want to expand until you get to the smaller one. Okay, so 8 is my larger factorial, so I'm going to expand it to 8 times 7 times, now am I going to go 6 times 5 times 4 times 3, 2 times 1? No, we can write it as just 6 factorial. 8 times 7 times 6 factorial all over. Now 2 factorial is just what? 2. So let's get rid of that factorial. Times 6 factorial. And now what reduces? 6 factorials. Woohoo! 8 times 7 divided by 2. 28, 50. Yeah, and you could even reduce this 8 and 2 to 4 times 7 if you want. And that's 28. So, let's take it up a notch. It's too easy, right? Boom. Let's throw in some n's. Okay, so always enlarge, especially if it's a fraction and we're going to reduce, always enlarge the larger one. So who's larger, n or n minus 1? N is larger than n minus 1, right? In fact, it's 1 larger. So we're going to expand n factorial until we get to n minus 1. How do we do that? We keep subtracting 1 from it. So n factorial can be written as n times n minus 1. Now, I don't have to keep going. I don't have to keep writing this as n minus 2. n minus 3, because I got to n minus 1. So now I can just write that as n times n minus 1 factorial. It's just like if we had 9 factorial over 8 factorial, I could write the 9 factorial as 9 times 8 factorial over 8 factorial. Same idea. So n, subtract 1 is times n minus 1 factorial, because we got to the n minus 1, and now it cancels out. Be very careful, factorials can cancel out factorials. If this didn't have a factorial on the bottom, they wouldn't reduce out the whole thing. Okay? Only part of it would. And so that simplifies to just n. Okay? So how else could we write this one? n plus 4 times n plus 3 times n plus 2 factorial. Let me give you a hint. 9 times 8 times 7 factorial. How did we just write that? 9 factorial. No, because the n's important in there. Yeah. So how else could we write n plus 4 times n plus 3 times n plus 2 factorial? N plus 4 factorial. Okay, who's larger, n plus 1 or n? N plus 1. Okay. Yeah. N plus 1 is bigger than n. So we're going to expand the n plus 1. N plus 1 times, what's 1 less than n plus 1? N. Can we stop? Yeah, we got to this n, so we can just write that as n factorial over n factorial. And now what reduces out? N factorial, so this is equal to n plus 1. Okay, and you can kind of check your work. What? Oh, well, I'm gonna add another question. Okay, underneath, example 6. Haha. Sorry, it's not in your notes. Write this in. Example 6. Solve. I'll put this higher for you. Solve n plus 3 times n plus 2 factorial all over n plus 1 factorial equals 30, where n is an element of the natural numbers. Okay, did I bring it to another level? Darn it. Now, when we look at our factorials, it's the factorials that we expand. Okay, who's the larger factorial here? So this factorial, who does it belong to? This one that I'm pointing to right here. It belongs to just the n plus 2, whoever it's beside. Okay, if n plus 3 was a factorial, it would have one beside it as well. So we're comparing the n plus 2 factorial to the n plus 1 factorial. Who's larger? N plus 2. M, whoop. I'll use blue. N plus 3 will stay the same. So n plus 2 times 1 less than n plus 2 is what? N plus 1. Can we stop? Yeah, because we got to the bottom one, so we'll leave that as a factorial over n plus 1 factorial equals 30. Now what happens? Fun stuff? N plus 1 factorials reduce out. Good. Now, n plus 3, we're trying to solve for n here. So in order to solve, this goes back to quadratic equations in grade 11. In order to solve a quadratic equation, we do want factored form, but one side of the equation has to equal to 0. It doesn't. So that's a problem. So we need to expand this or FOIL it out. Do we remember how to do that? We could use distributive law. So there's two ways. I'll show you both. Distributive law says n times the n plus 2 plus 3 times the n plus 2. Do you remember that? Or you can use FOIL method, n times n times 2, 3 times n, and 3 times 2, which is really the same thing because I'm going to have to use distributive law here. Okay, so they're both going to give you the same answer. Do you know what I'm talking about? No? Yes? Okay, hope so. N times n squared plus n times 2. And you can do it this way as well, 2n plus 3 times n is 3n plus 3 times 2 is 6 equals 30. What can we do now? Collect like terms, the middles, n squared plus 5n plus 6 equals 30. Now whenever we have an n squared, we want to get everything to one side and then factor. So who do we have to move? So everything's on one side. Subtract the 30. We have to move the 30. N squared plus 5n. 6 minus 30 is negative 24 equals 0. Now that we have one side equal to 0, we can factor this. So this is a simple trinomial. So factoring is easy. Usually on your diploma, they'll only give you simple trinomials or difference of squares. And you're going to get to a rational expressions unit. It's the last unit you're going to do, and you'll practice lots of factoring too. Okay, so remember this guy is your sum and this is your product. We want two numbers that multiply, or product is negative 24, and two numbers that add, their sum is 5. So what are those numbers? 8 and 3. Who's negative for adding to 5? The 3 had to be negative. So does 8 times negative 3 equal negative 24? Yep. 8 plus negative 3 equal 5? Yep. So we can go straight to factored form. So I can go straight to the back brackets. So our product is n plus 8 times n minus 3 equals 0. So if this is a product, this product equals 0, then that means either n plus 8 equals 0 or n minus 3 equals 0. Do you remember this from quadratics? It's coming back to you? Good times? No? Okay, so n plus 8 equals 0. What would n have to be? Negative 8. If we subtract 8 to the other side. If n minus 3 equals 0, what would n have to be? Add 3 to the other side, n is 3, right? Would you agree 3 minus 3 equals 0? Yeah. Would you agree that negative 8 plus 8 equals 0? Okay, which one of these can we reject? Which one would we reject? Negative 8. Remember that n has to be natural numbers, counting numbers, so it can't be a negative value. So our solution is n equals 3. And you can check your answer. So you can go back to the original equation. So 3 plus 3 is 6 times 3 plus 2 is 5 factorial divided by 3 plus 1 factorial is 4 factorial. And so if you type that into your calculator, 6 times 5, math, 4 over 4 factorial, 30. There's your answer, there's your check. Okay, so you can check your answer. Fun? I'm going to go back up or no? Okay. I'd like you to, is there a room on your next page? Is there a note section at the back of I believe there is a note section at the very back, or a blank page after the Sudokus. We're going to do one more example. Okay, the very last page of your book, it's blank. You're okay with that. Solve n plus 2 factorial over n factorial equals 20. And n is an element of the natural numbers, of course. They're always natural numbers. Let's write that down, because I'm going to add 2 questions like this to your homework. Sorry, your homework's 1 page in the workbook, and then 2 questions I'm going to add. Okay, who's larger, n plus 2 or n? Do you everyone have it down? I'll wait a second. N plus 2, so we're going to expand the n plus 2. So n plus 2 times, what's 1 less? N plus 1, now we haven't got to the n, so we keep going, times, what's 1 less than n plus 1? N. Now can we stop? Yes, because we got to the n factor. So n factorial over n factorial equals 20. Now we cancel out the n factorials. Can I say my answer is -2 and -1? Or what's wrong with this? It's not equal to 0. It always has to be equal to 0 to say those are our solutions. So we don't have that, so what do we have to do with this binomial? Times binomial, we need to expand it. Okay, so I'm going to use just the FOIL method this time. N times n squared, plus, then the n times the 1, 1n, plus, now do the 2 times each of them. 2 times n, 2n, and then 2 times 1, 2. Okay, what can we do on the left side? Collect like terms. So 1n plus 2n, and the like terms are always in the middle. If we have a quadratic that we want to solve, what do we have to do? One side has to equal to 0. So who has to move? 20. Subtract the 20 over. So 2 minus 20. N squared plus 3n minus 18 equals 0. Okay, now we can try and factor. This is a simple trinomial. Remember, it's simple because there's nothing in front of the n squared. It's not a complex. We want 2 numbers that sum to 3. Product is -18. So sums to 3, product -18. So always start with your product. We need to think of 2 numbers that multiply to -18. 6 and 3. Who would be negative? And we know one of them has to be negative. Our product is negative, so 1 positive, 1 negative. If we're adding to 3, which one's negative? Okay, -3. Are you mocking me, Levi? Never. Never. Okay, so then we can go straight to factored form. We can just input our 2 numbers. So it'd be n plus 6n minus 3. So one of these is 0, so that means either n is equal to, what would n have to be for this to be 0? -6, or n is, what would n have to be for that to be 0, for that product to be, or that binomial to be 0? 3. And which one can you reject? The negative has to be natural numbers, so there's our solution. Okay? And again, you can check your answer. So our original question was n plus 2 factorial over n factorial equals 20. So if I plug in 3 plus 2 is 5 factorial over 3 factorial has to be equal to 20, and it does, because it's 5 times 4. The 3 factorials would cancel. Okay, so I'm going to add 2 questions. You can maybe add them to that page for your homework, and then on page, it's just one page, page 29 in the workbook for homework. So the 2 questions are the following. Please write them down. They're a little easier than these ones that we just did. Okay, so homework questions also. Number 1, so solve for n. And, n minus 1 factorial divided by n minus 2 factorial. Question, who's bigger? N minus 1 or n minus 2? N minus 1, thank you. Okay. Equals 3. And number 2, n factorial all over, there you go, n minus 2 factorial equals 12. Okay. So those 2 questions, and then page 29. 2.2, which is on page 29, which is really short. Okay. And that's today's. The solutions for these 2 questions are worked out on the website, so you can pull them up if you're having issues, okay? And you should be able to check your answer once you get the answer yourself. But if you are having troubles, they're on the website.